I want to talk about DNA, information theory, and intelligent design. So it was a good segue because we're now talking about biological information. Most of what I'm going to talk about right now is from the work of these two guys. This is Bill Dembski, and his classic book, The Design Inference, is where I got most of my probability analysis things. And he's a mathematician thinking about complex systems. So his is a lot of, you should read his book. It's a hard book to get through because it's a lot of statistics and math. But I'll boil down the basic take-home messages here. And then the other guy is Stephen Meyer. Stephen Meyer is actually a philosopher of science, was at Cambridge, and now he works for the Discovery Institute. And his most recent book is called Signature in the Cell. So most of the biology I get from Meyer, most of the probability I get from Dembski. And I want to bring up what is called the DNA Enigma. Does anyone read digital code, binary code? Probably not. This is the American Standard Code 2. It's actually American Standard Code for Information Interchange. So the ASCII. This is the digital code for language, right? And it's an agreed upon kind of, not universal because there's other codes out there, but it's the standard one, right? And this is the binary language for English. This is actually parts of the Gettysburg Address, right? Which was 7 years ago, our fathers, right? So I forget how long it is. I think it's like 7 or 8 digits are coding for a single letter, right? So when you say something like 0101011, something like that codes for the F, the beginning letter in 4 score, right? And you could go look this up. You can write code if you want, right? The DNA Enigma is the DNA sequence is almost identical in terms of its information content as this, right? This is obviously a code that we have agreed upon that says this digital code codes for the letter F and so on, the whole alphabet, and you can write things in this code. Well, DNA is the same way, right? We've just talked about translating nucleic acid language into protein language, right? Which is the same thing as digital code into English letters, right? We could translate this into English. We could translate this into protein language. So the DNA Enigma says, this is the human genetic code. And I grabbed sequence for RNA polymerase because we just talked about RNA polymerase, right? So if you follow this, where is the ATG? I can't find it. I don't know. I don't think I put in the ATG. There should be a start methionine that we could find there. But this is the part of the code for the RNA polymerase. The DNA Enigma is, if there's information here, if there's 2 languages, and there's a code to translate languages to one the other, what was the origin of that code, right? What is the origin of biological information? So let's talk about, well, here. I'll give you a couple of quotes, too, to illustrate this enigma that's out there. This isn't something that I just made up. It's not actually even something exclusive to the intelligent design community. So here is Bill Gates. Knows a little bit of something about coding. And he says about the human genome, he says, human DNA is like a computer program, but far, far more advanced than any software we have ever created. So I want you to think about the genome as being software, right? It's information in a code that's telling the cell to do certain functions. It's not even, so it's not just an intelligent design thing, it's a computer programming thing. And even avowed atheists like Richard Dawkins says, the machine code of genes, so the genome, is uncannily computer-like. Apart from differences in jargon, the pages of a molecular biology journal might have been interchanged with those of a computer engineering journal. Right? Now, one is obviously designed, right? Bill Gates and computer engineering journals, the human people coding information into some media, right? You could do it in lots of different medias, right? You could burn it onto a disk, or it could be in flash memory, or and you could chisel ones and zeros into stone, right? It doesn't really care what the media is. It cares what the code is. But then at the same time, naturalists want you to think that that second example, the DNA example, is not come about because of human or any intelligent coders. So Francis Crick says, biologists must constantly keep in mind that what they see was not designed, but rather evolved. He says, you're going to look at it and it's going to really look like it was designed, but you got to remember it wasn't, which seems counterintuitive, right? But I'm going to put some points to it, okay? So first I want to say, what is information, right? If we're arguing about whether information can come about by only human coders or by natural processes, we need to get a definition of what do we mean when we say information, okay? So information is really any ordered sequence of symbols. Any ordered sequence of symbols, right? I could etch hieroglyphics into stone. You could program a circuit to hold ones and zeros for you, right? So any ordered sequence, but the medium must be contingent. That is, the medium, the thing that you're writing in, must not dictate what gets written down. Right? If you're writing in stone, you can carve whatever you want into the stone. Right? There's nothing intrinsic about the stone that says you have to write any certain sequences, any certain hieroglyphics. Right? You could draw whatever you want. It has to be contingent. So it can't be dictated by natural law. Right? You must be able to put the nucleotides in whatever order you want, and the chemistry must be indifferent to that. Right? For it to hold information, it can't be dictated by the medium. And then we say information is present in a medium when possibilities are ruled out, right? If I've taken up some space in the stone and written down a hieroglyphic, I have eliminated the ability to write other things, right? So I've put some information there, right? I've just changed it in an exclusive way, right? So there's actually several types of information. And I'm just going to walk through a couple of these because they become significant when we try to talk about, can natural processes make any type of information? Okay. So the first type of information is called Shannon information. Shannon information is the reduction of possibilities or the reduction of uncertainty. Basically, it's just saying there's a pattern, right? Maybe the pattern's repeating, and maybe that can come about by naturalistic processes, but at least there's a pattern that's eliminating other possibilities. Right? I'll give you examples of this in a minute, but let's just get the definitions down first. The second type of information is prescriptive information. That's instructional information, like algorithms, equations, things that tell you how to do certain things. Right? So if you write mathematic equations, that's communicating information. It's communicating information about what to do, right? A function. That's prescriptive. Functional information, so I shouldn't have used functional in my previous definition because it's going to clutter things. So functional information is useful, purposeful, meaningful things. Right? This is like saying words to each other. Right? And we're not just saying chemical equations or just a map or something like that. We're actually talking and saying functional things. Right? So I'll give you examples of each of those. We'll see if we can make through that. Here's Shannon information. If you took some dice and rolled the dice, there's Shannon information there, right? The dice have rolled onto a certain side, and they've excluded any other side from being the one exposed, right? So Shannon information is purely probability-based, right? There's no functionality required. I don't have to have any agreed upon thing that these dice are doing. I'm just saying there's a sequence of dice, right? That's Shannon information at its lowest form, okay? You can have low or high information content, and it still can be considered Shannon information, okay? So the example of this is ways for dice to roll 7, okay? This is low information because there's lots of ways you could do this in the dice, right? You could roll a 6 and a 1, that gives you a 7, a 5 and a 2, a 4 and a 3, the other 3 and the other 4, and alternate ways, right? There's 6 different ways to code for 7. This is all just Shannon information though. This is just low density, low information content, because there's multiple options I could do to do that, right? High information content, high information Shannon content is that there's only one way to roll a 2, right? There's only one way to roll a 12, right? That's just Shannon information, right? We're just talking about how to make the numbers, but high or low. This should give you a clue as to why certain dice games are set up the way they do, right? If you're rolling craps, if you hit a 7, you're out, right? Well, 7 is the easiest number to come up with, right? Because there's 6 ways to do it, right? And if you get snake eyes or if you get 12, that often means big payout because that's hard to roll, right? But this is all just examples of Shannon information. Another example of Shannon information could be in English, right? I could write junk, 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 junk. It's just repeating. There's no real depth to it, right? But it's information, right? Because I've set it up in a certain way and it's not another way. So only here is the first iteration. That's the only informative thing is junk, right? And unless we came up with a more elaborate code that said, if I say junk 3 times, what I really mean is cool, right? That wouldn't be Shannon information anymore. But Shannon information is just this level of repeating units, right? Yeah.
Does Shannon information need to be, maybe you just said that, I'm not sure. Does it need to have some relevance to us? Like if you said junk, I know junk's a word.
Yeah.
For instance, if you just said JPQZ4.
Right, and then I just said that over and over and over again. That would still be Shannon information.
That's still Shannon information.
Yeah, yeah. So maybe this is a bad example because it actually kind of brings in some functional information, because you and I have already agreed that junk means a certain thing in life, right? So it'd probably be better to put a random sequence and just show it over and over. Okay. All right. Shannon information. You could sometimes compress things. Like I could have low information here. This would be a lot of stuff. I can compress that all into just one. So zip files actually do this. Zip files take some of the Shannon information that's in a sequence and just compress it. And so you can make your file sizes smaller. So this is actually going on in computer codes and stuff. I just want to say that because there are certain types of information that is very, very high maximum Shannon information. That's random data, right? Junk, 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 junk. I don't have to draw that all out. I could just say junk 5 times, right? That would be compressing that information, right? But if I had a long sentence of all unique words, you can't compress a sentence of all unique words any further, right? Because it's got high Shannon information. It's very specific. There's only one way to say that whole sentence. You can't compress it anymore. That's just an example for you to think about low information content. If it's low information content, I can compress it. If it's high, very particular information, you can't compress it anymore. So there's a limit to how much you can compress files in a zip folder, right? You can only get them down so much because some of it has to remain in its very long sequence. Okay, that's Shannon information. I want to talk about functional information. I'm going to skip the algorithmic stuff because I think the DNA is representative of functional information. Okay. So here's functional information. Here's some coin tosses, and no, the resolution did not come up well. This would be, it could look very simple, right? I could just turn over a series of coins, but I could turn over a series of coins in a way that actually codes for functional information. So here's coins. If you turn coins over so that heads is a 1 and tails is a 0, you could use coins as your medium for doing ACSI code, right? So this is a bunch of random coin tosses. Here is a specific amount. So this is just random though, right? Random coin tosses, 0s and 1s, is creating Shannon information. Functional information is when the sequence of things means something. Okay? So here, 426612, that is the Minneapolis zip code, right? So if we're thinking about it just as the numbers, it's got Shannon information, because at least it's excluding possibilities, but it additionally has functional information. So functional information requires that two parties have agreed upon something that this is going to mean, right? It's just not random numbers, it's just not random dice. It's functional information because it tells you something, mainly Minneapolis, right? That can't be due to the dice itself, right? The dice do not determine that that is the zip code for Minneapolis, right? It's two independent people. You know, at some point, somebody had to decide what the zip codes were going to be, right? And those people put the information there. So I can represent it in a bunch of different media, but this is functional information, right? So the information, don't worry about the pattern match and probabilities. Information is determined by protocol rules. Rules that we have decided upon, not any chemical laws, right? It's not the probability of coming up with something that tells you it codes for Minneapolis. It's people that decided that, right? So that's functional information.
Biola University offers a variety of biblically centered degree programs, ranging from business to ministry to the arts and sciences. Visit biola.edu to find out how Biola could make a difference in your life.